Okay, today's going to be a tough day. We're trying to fix a very complex problem. And we've got to do it in a couple different areas. So it's like, one thing we're trying to do is, if we're surrounded by two standing stones or capstones, and the third space is a stack, a high stack, because our limit is 14 occupants for any given space, because that's all we can realistically render with still having legibility in there. We have to prevent. Okay, so this is where it's tricky. We've got to prevent a legal move from being true if the amount of occupants in our current grid plus the amount of occupants in the stack would be equal to 14 or more than 14. So we're trying to falsify that so that you can't pick it up if there's no legal move, because we can't have our player drop a stone on a 14 stack. It'll crash. So we have to stop them from being able to even pick up a stone if their only legal move would be on top of a stack. That would put them over the 14 occupant limit. But then we also have to, this is complex because we also have to stop that. So like that would stop us from ever picking up the stone if we were surrounded in a scenario like that. But we also need to, once we've picked up the stones, we need to check whether or not the space it would be the first movement grid. We need to check whether that occupant plus our stone's occupant would be greater than 14, and if so, then that is not a legal move. So we need to stop ourselves from being able to pick up the stones if we can't drop any on a stack, and we need to stop being a legal move if our current stones plus the occupants that we would select in our first movement grid would be more than 14 as well. Now there's a whole issue here where, let's say there was a 14 stack right next to us, or a 13 stack right next to us, and we had a stack of 5 here. We could technically pick up 5, only drop 1 in a 14 stack, continue to move over and drop and kind of go over that. But the more I think about that problem, the more complicated I realize it is, and it I don't want to say that I'm giving up on that idea, but I kind of would be if I give up on that idea. In order to do that, in order to allow that functionality, we would need to check whether or not only the next space would be able to handle 1 stone or more without being over the 14 occupant limit, but then check if the next space is able to hold all of our occupants. And if so, we would force the player to only drop, up to our occupant limit in that first grid. And then that's actually sounding somewhat doable, because once we have our first grid locked in, well, actually, that's where it gets confusing, is we would need to kind of map out what the next grid would look like if we were to click on that first movement grid. So it's a very complex problem, in my brain at least. my limited coding experience brain. So where do we even start? Let me give us a thing here saying we need to prevent legal move if that grid's occupants plus the neighboring occupants. God, this is so confusing. There's so many things to keep track of here. I'm going to confuse myself if I try to build that out. But right here in a movement event 1, before we even allow ourselves to pick up a stone, we need to see if the it's not that if our occupants are 14 that we're stuck, it's that if we were to put a stone in that surrounding occupant, if that would be more than 14. But it's more complicated than that, because if there's a standing stone just past that, once we lock in our direction, we would need to force drop all of our stones. So we kind of need to pretend as if we're dropping all of our stones in that first space. See, and this is the problem I was talking about, where we can technically only drop one stone and pass over it, maxing out our 14 occupant, but we're still able to do that as a move. It just gets so hard. Oh, it's really hard. Because if we do what we were going to do right here, we're preventing us from fixing, doing it the right way, which is we could pick up 5 stones, go on to a 13 stack, only drop 1, continue to move, and place the rest past it if that space doesn't have a capstone or a standing stone or another occupant of 14. God dang. I think the move is I'm gonna code a limit where it's not gonna be a legal move if if the stones you pick up in your space could be up to 5 stones. If that plus the occupants of whatever that grid is, if that plus the occupants is more than 14, then we're gonna make that a legal move false, meaning you just can't do it. And then when we're debugging and playing, if there comes a time where we want to do a move like that, where we want to drop only 1 stone on a 13 stack and move over it, then we can rack our brains and try to figure out how we would make that possible. But from what I've seen in the professional TAC games, even on a 6x6, the stone stack height doesn't really go more than 12. So I'm hoping that issue doesn't come up that much. I know that's kind of a bad thing to say, but it's just really complicated to do it right. I'm kind of stumped on how the workflow might work to do that, but we can figure it out. I guess for now, let's just do the easy fix, and it might give us some insight on how to do the real fix. So, how do we check So it's not that we're trying to check whether or not that it's surrounded by a 14 occupants. It's that we're trying to check whether or not our grids... No, hold on. We're trying to check whether or not the grid we're determining legal move for, if that grid's occupants. Now it can't be bigger than 5, so if this is more than 5, we need to limit it to 5. We do this, man. We can do a math dot max, no, math dot min. Yeah, math dot min. We pass it in our occupants plus the occupants of the surrounding square, and 5. So if this becomes more than 5, we're just limiting it to 5. But hold on a second. God dang. Yeah, math.min to limit us to... Yeah, we don't want to do this plus occupants just yet. Our music stopped. Okay, so our occupants and 5, whatever is the smaller value, we're gonna add that to our grids that we're trying to check occupants, and if that value is greater than 14, then we do not want, or then we would need to make a legal move false. So it's not that we're checking whether or not there's 14 occupants. And this actually, yeah, this is hard coded at 14, so this would only negate something. Let's say, for example, we had 13 occupants and then we pick up 5 stones. At that moment, God dang, it's so confusing. That's a hard problem. That's a hard problem. Okay, we're trying to see if our occupants plus the grid's occupants is greater than 14. And if it is, we'd be a legal move false. This is just for the corner case. We have to implement this for all the corner cases, then all the edge cases, then all the middle cases. You know what? We don't even have our middle cases yet. We just did our edge cases yesterday, so we've got to do that still. So maybe before we tackle this, let's just try to tackle our let's just do our middle cases, and then we can worry about this. I'll give myself any excuse to put off this. And it's not, or it's 1, 2. Okay. So let's do our middle cases surrounding. So if we're surrounded by illegal moves, see, and it's so tough because you can move any direction, or, you know, any legal move direction you could move is dependent on the occupants and the stone control, and if we want to do it right, the next possible moves depending on how many occupants are in that space and how many occupants you have. So it becomes such a hard problem. Let's just worry about our middle cases right now. So we're checking through every grid. Now, a middle case would be if our I does not equal 1 and our I does not equal 5, meaning our row is not the very first row or the last row, and column is not the first column and it is not the last column. And if I is not equal to any of those, then we know we're a middle case, which means we need to check all spaces around us. We need to check all surrounding spaces for a legal move. Yeah, this is tough. This is tough. In a perfect world, we don't have to worry about limitations of occupants, but this game can't realistically become a 40 stack and still render that on a 2D screen. It just doesn't make any sense. So let's figure it out. See, we need to do, the good news is we do all the same arithmetic no matter what space we are in a middle space. So that's different than all the other cases, because depending on what side we're at depends on the change the illegal moves. So now that we just have to check all the surrounding spots, it's going to be fairly easy. So we're going to say that if we're a middle case, we would need to do a top side, a bottom side, a left side, and a right side. So our top side would be our grid at our row minus a 1, but a same column. That would be the square above us. So we would say if the grid right above us has a stone control equal to that of a standing stone, or a capstone, or and this is where this gets confusing. But right now we're going to do our same old logic of just checking if our occupants is a full stack, which isn't necessarily what we need to check, because we could technically carry stones into that stack. So, but for right now, we're just going to say that grid for right now, we're just going to do this like we've been doing it, with just testing for 14. And I want this to be actually down here, up here. Okay. So depending on which middle spot, we need to check all of these. And only if all of these are true, if we're surrounded on all sides, that's when we would falsify our legal move status for our middle edge cases. Not edge case, but just middle case, I guess. So that's the top. So then we could say else if now our bottom would be same column but row +1. So I'm just gonna say that this is now a plus because it's one space beneath us, not one space above us. We're checking stone control to be a standing stone, capstone, or an occupants of 14. Then we need to check our same row. But left on the column. So this is not a +1 anymore, it's the same row, and it's a column to the left. So it's regular I and a J -1. Okay. Okay, now our right side would be our same column, but AJ +1. So it's very similar to this. So this is just checking every single space around it. And if every single space around it, actually we don't want these as an else if, we want them inside each other. So we would first see if the top is stuck. Then we would check if the bottom is stuck. So this would be top, bottom. And then we need to put it nested like this because we need all these ifs to be true in order to falsify that legal move. And we'll put our left in there. Okay, so only if we are surrounded on all of our sides and we're middle case, that's when we would falsify our legal move, which would prevent us from picking up that stack in the first place, because there is no place to put that stack without overdoing our occupant max of 14. So if all those things are true, then our grid at IJ dot legal move would become false. And we only need to do this. We only need to do this if we are in fact a legal move true at this point in time. So, legal move. I'm going to say if that grid is a legal move, then if we're surrounded, that's when we would switch us to a legal move false. Otherwise, we don't even need to check any of these conditions because we're not a legal move anyway. We don't need to falsify anything. So in order to test this, I'm gonna make sure a 14 stack is one of our directions. So here, there's a 14 stack right there. Now we're surrounded here, we're surrounded here, we're surrounded here. We're in a middle case, and it's our turn, and it is not a legal move, yet these are still legal moves. So I'm thinking we did that right. But the problem comes when we have, let's say, for example, we have a couple stones here. And so look, we have 5 stones here, and we're surrounded here. This is why we can't do that occupants is 14, because at this point it'll be our stack control. We are in fact a legal move because this is only 10 occupants. It does not equal the 14 occupants, so this is still saying it's a legal move. Yet, when we click on this and lock in all 5 stones, this is not a legal move, this is not a legal move, this is not a legal move. This is, and that's the only space to drop stones, meaning once we drop stones, we cannot end our move unless we drop all 15, which once we drop our 15th, we crash. So that's why this isn't correct. We're not trying to check whether or not there's 14 occupants. We're trying to check whether or not the grid we're trying to do has up to 5 occupants plus the amount of occupants surrounding. And if that is greater than 14, then we can't become a legal move there. We just cannot allow us to make that move because we could potentially crash our game. So let's try our math min function, or our math min logic here. In this case, so it's not that we're checking for this grid to be 14 equal to 14. It's that we're trying to see if the occupants in that space, this should be if the grid we would move it to, which is this grid, if that one, this is tricky. Get rid of this because it's confusing me. So we're trying to see if the space we're moving to plus up to 5 occupants from our current space, which we can get through math.min. We could say our grid at our ij dot occupants, and it's that dot occupants as well as a 5. That's where the math min locks it in. The highest number that can be is a 5 because that's the most amount of stones you can pick up. So this means that if there is 9 occupants on top of us and we're surrounded otherwise, we still cannot pick up that stone because it would mean we would have to dump 5 occupants in a 9 stack, which would put us, well, that would put us at a 14 stack, which would be legal. But if we have 10 stones there, we cannot pick up a 5 stack. Now we could either such a complicated thing. So we're trying to see if our occupants plus the occupants of the next grid is greater than 14, and if so. I'm going to put these in a parentheses. Now, we want this code to be like this. Trying to see if it's greater than 14, and we're trying to see if our space plus that occupant is greater than 14, limiting it to 5. So that's kind of tricky. But this plus our occupants is greater than 14. So I'm hoping this will prevent the bug we just made crash our game. So if we put 10 stack, so let's see if that works, like a 10 stack right above us. This is currently a 10 stack, so that works perfect. We would need a 5 stack here, right? So there is 3 stack. There's a 4 stack and a 5 stack. Now we're trying to lock ourselves in, forcing us to move onto a 10 stack with 5 stones. And this should, if we did our code right, then this grid should not be a legal move. So let us go to a move type move. It is not a legal move, yet we are here. So that's looking like it's working. I'm wondering if we can do something similar, but with, we'll say only 4 stack, right? So we say, now that we have a 4 stack here, I want to move this white out of this space so we can surround with capstone or standing stone. Now, this black move here should be legal now because there's only 4, and 4 plus our 10 is not greater than 14, it's equal to 14. So if we did our code right, this should be a legal move at this point, which it is. And that looks to be, if we can pick this up, we lock in all of our stones. The only legal move we have is up here, and we can dump all of our stones in there without crashing the game because that's a 14 stack limit. So I think that's right, but we do have to, we can get a little more clever and prevent, we can get a little more clever. Ooh, that's weird. I've never had the reset button crash our game, but come on, man. Why do you do this? I don't know why it's doing that. It's just one of those things. It's been doing this where it breaks and then you just load it again later and it doesn't break. So that's just really weird to me. So the thing I want to try to figure out is, let's say we have a 10 stack right there. And we have a 5 stack that we're trying to move on top of it, which at this point is illegal. But, okay, now we've got a 5 stack there. I'm gonna move this black out of the way surround us. So here's the other idea that I want to implement is that right now this is illegal because all of our stones placed on that stone would be an occupant of 15, which would crash our game. But if we wanted to, we should be able to only place 4 stones on that stack because it can hold 4 more stones. So the fact that this is an illegal move right now, just because we could potentially put all 5 on there, isn't very fair, because we could only, if we wanted to just move our top stone on top of it, we should be able to do that. Or if we wanted to move our top 4 stones on top of it, we should be able to do that, because that would be a legal move. So how do we allow that? Well, it would be in what, a movement event 3, where we're deciding how many to, no, it would be in a movement event 2, deciding how many stones to pick up. But at the movement event 2 point in time, we don't have a way to check whether or not our legal moves. Oh my God. This is so difficult. We have to figure this out, because this should be allowed in the game. I'm only going to put 4 in our stack here so we can test. At this point in time in a movement event 2, we need to check it's like we need to limit. Oh, see, and this is the other thing, is we default to picking up the max amount of stones. But what if instead of picking the max amount of stones, we pick the max amount of stones we can legally move? Let's take a peek at our end of movement event 1 logic so we can determine how many stones we pick up, or see where that is, and see if we can figure out a way to say that instead of picking up 5, we pick up we count how many occupants are in each surrounding grid. We probably have to do corner case, edge case, and middle case again for that, because the grid is nil if we just search every grid around us, which is tricky. But we can say that the amount of stones we pick up isn't actually 5, and it's not just the top 5. It is the top amount of stones that could be placed in any surrounded place. We need the highest amount of stones that would still be under 14 placed in any direction around us. Jesus. Let's take a look at the end of our movement event 1 and see what that's looking like. So here's our movement event 1. We do it right here. It's called stones to copy. Now what if stones to copy is not just 5. What if stones to copy is 5 if if all of our surrounding occupants have 9 or less stones? Sure, we need to copy all 5. But if we have 10 stones, we only need to copy 4, because you cannot place more than 4 stones into a space. But the thing is, we only need to do this if we're completely surrounded otherwise. Because if there's a 15 stack, 14 stack right next to us, yet an empty space next to us, we still want to be able to pick up 5. Oh shit, that's so complicated. Because then do we pick up 5 or pick up 4? And then how do we limit? Oh my god, oh my god, oh my god. Holy crap. It's a huge problem. It's a huge problem. Because we want to be able to pick up 5 if we're not completely surrounded. But if we're not completely surrounded, we pick up 5, yet there is more than 5 in our hand. At that point in time, we cannot have a legal move be on an occupant that has more than our occupants plus that grid's occupants being equal to more than 14. But we could dump. Shoot. Yeah, so if you lock in 5, then you can't move on that stone, but if you lock in 4, sure, you can move on that stack because you could dump 4 on top of a 10 stack. Have that still be legal. I think it's possible. My brain's breaking thinking about it, but I think it's possible. I don't know where to begin. God, I don't know where to begin. Because here, so this actually isn't. Oh my god, I don't know how to do it. I don't know how to do it. Because this is before we decide how many stones we're picking up. And how many stones we're picking up determines whether or not this legal move is true or not. Oh my god. This is the hardest problem I've been trying to wrap my head around in programming. I can't think of a harder thing to wrap my head around that I've tried to pull off. I mean, we could... This line of code, these lines of code are preventing us from picking up... Actually, it's preventing us from picking up any stones if the surrounding stones were trapped, or if that all of the max stones we pick up, if we were to pick up max stones, which we haven't even decided that yet, if that would be over 14 stones once we dump on anything surrounding the area, if all the other ones are also blocked. So, long story short, we aren't trying to falsify a legal move here. So in what case do we know we need it to be false? And we know we need it to be false. Oh God, I don't know, dude. Okay. I think I'm getting the hang of it, of the problem, you know, because it's like we're trying to. I think we were onto it when we said whether or not the grid at this place, which in this case is an I-1 and a J dot occupants is equal to 14. So right off the bat, we need it. We need to prevent us from picking it up if the only space we can move into this is very complicated. Because if we do this, then a surrounding grid would have to have 14 occupants in order for us to not be able to pick up that stone, period. Now, we don't render our legal moves for our first movement until we decide how many stones are picked up in our movement event 2. Because this is still movement event 1, right? Yes. So at that point in time, then we would do this math.min for how many stones we actually picked up. And if however many stones we actually picked up see, but then we need even one more step where if I don't know how to do it, man. I don't know how to do it. How do we ask if we're surrounded on? How do we modify the only space we're not surrounded on? Oh God, I'm confusing the crap out of myself. Let's continue to go this route and see if we can't figure it out. So we're gonna do the same thing here, because we don't want to limit this before we know how many stones we're actually picking up. So we can just make sure that we're doing the right logic here. I+1J, good. Then this is I and J minus 1. And then this would be I and J plus 1. Okay, so at this point, we're preventing us from picking up any amount of stones in a grid that is surrounded by either capstones, lace stones, or an occupant of already 14. So if occupants is 13 or less, we can technically pick up a stone in our control if as long as there's only 13 or less stones. And then we would need to say if there Okay, this is coming along. When so we lock in our movement event 2 once we click on a legal move. So a legal move can still happen now if there's a 13 stack and we surrounding us, yet we have more than 5 stones. Now here, we don't want to copy 5 stones all the time now. Before this was the case, we would pick up a max of 5 stones, but we only want to pick up the max amount of stones that can fit legally. And this is the tricky part. Since we're checking each direction and we haven't locked in our direction, we lock in our stones before we lock in our first movement direction. So we actually need to set the amount of stones we can pick up to be equal to whatever our highest surrounding space would be. So the stack, the occupants, whatever the highest amount of occupants in any surrounded space. And then we'd have to do it for corner case, edge case, and middle case, which is not fun, but we need to check if, well, first of all, we need to check how many occupants are in those. And if it's less than 14, we can copy over 5. See, because here it's like, if we have less than 5 occupants, we copy over only however many occupants we have. But that's not right at this point, I mean, because we need to before we do this, before we assign the stones to copy, we need to check every surrounding space for the highest amount of occupants, and we can only copy the amount of stones that wouldn't place us over the limit if you were to place all of those given stones in the space, which prevents us from being able to pass over a stack if all of our stones were dumped in a stack, making it over 14 occupants. I really don't know how I would fix that if we were trying to do that. But we can at least do this. We can at least do this where we are able to place 1 stone on top of a 13 stack. We should be able to do that even if we pick up 5, or even if we're coming from a 5 stack, we want to be able to only pick up that top one and place only that top one on the only available space, making a 14 stack. We should be able to do that in the game. So before we set the amount of stones to copy, we need to get the, this is so tough, dude. Very tough. So just like how My brain is like on the verge of exploding thinking about this. Before we determine how many stones to copy, we need to check every surrounding grid for the highest amount of occupants that is around us and limit the stones to copy to be that number. Now, if that limit, if the highest amount of occupants surrounding us is 9 or less, and we have more than 5 occupants in our mouse grid, then we would need a stones copy to be equal to 5. And if we're less than 5 occupants and our surrounding grid, the max amount of occupants in our surrounding grid is 9, then we would have our same occupants of our mouse grid getting into stones copy. So the tricky thing is here we need to actually check whether or not we need to check every surrounding grid for every single possible case, which means we got to do corner case, edge case, and middle case to gather the highest amount of occupants that are surrounding us. That's really tough. I'm going to use the restroom and I'll be right back and we'll get going on this hopefully possible feature. I'm just dreading that I do all this work and then it just crashes like a monster and then I can't figure it out and then I'm stumped and then I give up. Like, that's what I'm really worried about. I want to do a little git commit here before I start to refactor or start to add all this stuff. in case we crash it. I'm going to say that this is added edge case, no, middle case illegal moves. And then this is before our occupant surrounding. I don't even know what to put for that. I'll just put added our middle case legal moves. And we'll get going on this update. So we're preventing ourselves from picking up a stone if a stone surrounding us is a 14 stack, because we wouldn't be able to place anything on there anyway. But if it's less than a 14 stack, then we want to limit our stones to be able to be, if it's a 13 stack surrounding us, we want to limit the stones to copy to be equal to 1, even if we have more than 5 occupants in our mouse grid. Right here, we're picking up all 5 if we have more than 5, which is fine for a majority of the game, but not if we're surrounded by 13 stack occupants. So the real tricky thing here is that we need to count the max amount of occupants surrounding our mouse grid. So yeah, we need to count the max amount of occupants and then limit the stones to copy to be equal to whatever that max amount of occupants is. The stones to copy can't, once added to that max occupant, can't be higher than 14. That will make it impossible to drop stones into an occupant. It'll limit the amount of stones we pick up to be equal to our highest amount of surrounded occupants, and have it be equal to 14. It's so hard to explain, but I think we can do it. And I think it'll work. So before we decide how many stones to copy, we need to count how many occupants are in our surrounding grid. So what if we make a function that says count, it would be highest surrounding occupants. So we run that function. Now in that function, we would need to give it this mouse grid, mouse Y grid, mouse X grid. We could pass in the movement origin row actually, which will probably be better. And movement origin column. So the parameter it takes is a row and a column, and then we need to do our corner case, edge case, middle case, and count the highest surrounding occupants. This shouldn't be too hard. So our highest surrounding occupants function, let's build this out. So we have a function called highest surrounding occupants. It takes in two things. It takes in a row and a column. I'm going to give us ij because I've been used to thinking of rows as I and j as columns. So we can just do logic on the I and j arithmetic. So we've got to do corner cases. we've got to do edge cases. And we've got to do middle cases. Now, we need a variable to store the highest surrounding occupants. We'll get to that when we get to that. But right now, if our I is equal to 1 and our J is equal to 1, that would be a top left. If our row is equal to 1 and our J is equal to 5, that would be a top right. If our row is 5 and our column is 1, that would be a bottom left. And if our row is 5 and our column is 5, that would be a bottom right. Okay. That's our corner cases. Now, what we need to do is do our arithmetic with a math.max, because we want the highest amount of value, highest surrounding occupants. So we want the biggest amount of occupants based on the amount of occupants in our surrounding grid. Now, in a top left corner, our surrounding grid would be a we can hard code these in because it's actually just two spaces, so we can say that it would be a row of 1 and a J of 2. So we would say 1, 2, if 1, 2 dot occupants, and our grid 2, 1, which would be second row, first column right beneath us, dot occupants. Now we're passing both of those arguments into this math.max function, which will give us the higher of two values. So we need to store that value inside of a variable called highest surrounding occupants, the value, not the function. Now, we hopefully only assign this based on one case. Which it works here for, I'm trying to think of how the middle cases would work. We pass in, that should work, that should work, that should work. That should work. So here, if it's in a top right, then we're wanting to math.max two values, first of which is to the left of us, so it's the same row, which is a 1, same row, and a 4 on the J column, dot occupants, and the other value is 1 beneath us, which in the top right would be the same row, same column, 1 row beneath us, so that would be a 2, and a 5. Second row, 5 over, yes. Same row, 1 to the left, yes. So dot occupants, and then our math.max would store that value inside our highest surrounding occupants variable, not function. Next, bottom left. Well, we're checking the one above us, so it would be the same column. So same J as 1, yet 1 above, which would be an I of 4, dot occupants. And then we also need our right space, which would be same row, which is 5, and 1 column over, which would be a 2, dot occupants. And then we pass those 2 into our math.max function, and we store whatever the higher of those 2 values into the variable highest surrounding occupants. Next, bottom right, we want to check whether or not our grid, one above our grid, which would be the same row, 1 less on, or same column, yeah, 1 above us would be same column, 1 row above, so it would be 4, 5, dot occupants, and 1 to the left of us, which would be the same row, which is 5, so we'd say grid 5, and then 1 column to the left, which would be 4, dot occupants. Pass those both into our math.max function, and we'll store the higher of those 2 values inside our highest surrounding occupants variable. Let's go on to edge cases. We need I think we want all of these to be an else if, because we don't want to assign any we only want to assign 1 highest surrounding occupants. Hold on. No, we can get away. If it's an edge case, we just need to limit, we need to only check we would know it's a top edge case if our I is equal to 1 and our J does not equal 1 and our J does not equal 5. That's when we're a top edge case. So this would be top edge, because we're a row of 1, first row, top row, and the J column is not equal to 1, the leftmost or the rightmost. So this would cover our top edge case. Now we would need, I guess we just go clockwise. What would our right edge case be? We would know it would mean a J of 5 because it's the rightmost column, and an I that does not equal 1, and an I that does not equal 5. That would be our right edge case. Now a bottom edge case would be, we would know the row would be equal to 5, our bottom row, and we know our column cannot be equal to 1 because that's the bottom left, and we know our column cannot be equal to 5 because that would be our bottom right. And then last but not least, the left edge, which here, let's just get, this would be a bottom edge. We need a left edge. Left edge we would know would have a row of 1 and a j that does not equal 1 and a j that does not equal 5. Okay, those are our edge cases. Now our middle cases, and we need to be explicit so we don't assign more than one value here. So we need to check, and a middle case would mean a row of at least 2. So if I is greater than 1 and I is smaller than 5 and our j is greater than 1 and our j is greater than 5, smaller than 5, then that would be a middle case. So let's go ahead for our edge cases. Now edge cases have 3 surrounding variables, 3 surrounding grids, all of which are at different indexes from one another. So if it's a top edge, we need the left side, the bottom side, the right side. Right edge, we need top side, left side, bottom side. So let's just do them one at a time. Top edge. Now we need to give our math.max function 3 values. Let me check that math.max can take in more than 2 values. If you could only take in 2, I don't know how we would do this, but it's actually I don't know if math.max can take in more than 1 value. It looks like it can. I want to see the man pages for this. I think we can do it. So, the first of which so if it's a top edge, we need our left side. So we would take whatever our we would take whatever our column is. Well, we know that the first one is a grid row of I, same row, j of 1 over to the left, dot occupants. Next value beneath us, which would be a grid, the row would be 1 beneath us, which would be a row of 2. We could probably more succinctly say this, or not succinctly, but keep it clear. I plus 1, a row beneath us, yet the same column, dot occupants. And the j that we're modifying here, or asking about, is the parameter that we're passing into our highest surrounding occupants function, which, if you remember, is our movement origin column. that gets locked in right at the beginning of, or the end of movement 1. Now the last value is the one to the right of us, which would be the same row. So a grid at our same row, but rj plus a 1 dot occupants. And then we would be taking the highest of those values, storing it in our highest surrounding occupants variable. Next. Right edge. We need top, left, and bottom on a right edge. So let's go for top first, math.max. Let's go for top first, which would be the same column, 1 row higher. So it would be an I minus 1, same column, dot occupants. That would be 1 above us. Then we need 1 to the left of us, which would be the same row, I, and a j of a minus 1. And then we need 1 below us, which would be a grid of the same column and a row beneath us. So same column, row beneath us, dot occupants. And we would store the highest of those values inside our highest surrounding occupants variable. Next. Bottom edge needs a left, top, right. So the top, the left value would be a same row. So grid I, same row, column to the left. Then we would need above us, which would be the same column, but 1 row higher. Should be that. And then we would need to the right of us, which would be same row, but 1 column to the right of us. And we would store the highest of those values in our highest surrounding occupants. Left side, we need a top, a right, and a bottom. So let's do top first. Top would be the same row, same column, but 1 row above. So right above us, same row, dot occupants. And we would need to the right side of us, which would be same row, but 1 column over, dot occupants, and beneath us, which would be our same column, but 1 row beneath us. So I plus a 1 at our same row, dot occupants. Now we're going to save the highest of those values into. Now ideally we don't assign more than 1 of these high surrounding occupants, depending on, first we're checking if it's a corner case, then we're checking if it's an edge case, then otherwise we're just assigning the highest of any surrounding grid. So let's get onto that. So we would need a math.max of 4 values now, all of which we need is just all surrounding. So let's do the left side first. Grid at same row, just left of us. Then we would need above us, which would be 1 row above us at our same column. And then we would need to the right of us, which would be our grid, same row, but to the right of us on the column. So j plus 1 dot occupants, and then we would need our last bottom space, which would be a same column but an I plus 1. But same column. Dot occupants. Now we're going to take the highest of those values, store them in our highest surrounding occupants variable. So we need to do a couple more things here. We need to initialize this first of all, which we'll do right here. We'll say, oopsie, we'll say it gets nil right off the bat. Yeah, we'll say it gets nil. And then we'll, under a player swap, we need to reset it also. So we'll say it gets nil here as well. The only other time this would be assigned is when we call our function highest surrounding occupants, which at this moment we're doing in a movement event 1. If we're in movement event 1 and we left click in a spot, that's when we're doing that function. We pass in our movement origin row. So now this function should update our highest surrounding occupants variable with the max amount of stones we can copy. Not necessarily, actually, it'll just be... Fuck. Okay, so now we got to do a little more thinking here. For example, if the highest surrounding occupants is 13, we need our stones to copy to be only 1. So let me see if I can see a pattern here. So if highest stone occupants is 13, our stones to copy would need to be 1. If we have 12, we would need to copy 2. If we have 11, we'd need to copy 3. If we have 10, we'd need to copy 4. If we have 9 or less, we would need to copy 5, but not exactly. So the thing here is we need to say right here we need to say if our highest surrounding occupants is greater than 9, so instead of just copying all 5, we would check whether or not we even have 5 or more to copy. Sorry, there's just like a net in here. Yeah, we would check if there is 5 to even copy. This is hard. So yeah, the amount of stones we want to copy depends on the amount of highest surrounding occupants and the amount of occupants in our mouse stone, or in the grid we click upon, which will become our mouse stones. So if we have more than 5 occupants in the grid we clicked on, then if we want to see if we copy all of them or not, that would depend on if our highest surrounding occupants is less than 9. If it's less than 9, then we want to copy all stones. If it is equal to 9, yeah, let me maybe say less than 10, because now if it's 9, if our highest surrounding occupants, this should be in occupants, yeah, with an S. If we have a 9 stack surrounding us, we can copy over all 5 stones. So if it's 9 or less, we can copy over all 5 stones, but we can only copy over 5 if we have 5 or more in our occupants that we clicked on. So that makes sense. But how do we decide? We can say if our highest surrounding occupants is greater than 9, meaning 10 or above, because we are limiting to a 14 stack. If our highest surrounding occupants is greater than 9, then our mouse stone is set according to our highest surrounding occupants, which if it's greater than 9, we need it to be our it needs to be It needs to be 14 minus our highest surrounding occupants. And we store that in our stones to copy variable. So let's walk through this with a 10 stack, for example. If 10 is the highest amount of surrounding occupants we have, so in any grid around us, the highest amount of occupants is a 10 stack, then stones to copy gets 14 minus 10, which would be 4, which if we have 10 around us, we can only copy 4 stones into our mouse stones, because if we were to place all those 4 stones that we did copy into the highest surrounding occupant grid, that would cap us at 14 occupants. So I think that's right. And then if our mouse grid occupants is less than 5, which is this else, if it's less than 5, we can copy over all of our stones. That's not right. That's not right. We can't copy all of our stones, because if there is a highest surrounding occupant around us, shoot, man, shoot. We would do something. exploding. So if we have less than 5 occupants, we still only want to copy over. So this used to be saying this would be say, hey, pick up every single occupant in our grid, put it in our stones to copy. But we don't want to just do that. We only want to do that if, I think we got to do the same kind of thing where we say if our highest surrounding occupants is smaller than 10, then go ahead and copy over every stone in your occupant, because even if you have 4, you can place all 4 on that highest surrounding occupants without crashing the game. Else if else if our highest surrounding occupants is 10 or higher, then we want to limit your stones to copy to be equal to 14 minus your current amount of occupants. No. Stones to copy, I guess it would be your highest surrounding occupants at that point. Because we can't copy more than we can place. Okay. What are the odds you think this works, guys? Well, we didn't crash right away. So we've got a 10 stack here, so let's put 4 right here. 4 in the stack below it. So now that we've got 4 in a stack below it, we should be able to, actually, let's put 5 there, because we're trying to decide yeah, so here's the magic moment. If we pick up a stone in our control from right here, it should only copy over 4 stones. So it should leave 1 stone there, which it does. Oh my god. Which means if we lock that in, we can place them anywhere. We can place all 4 here, leaving us a 14 stack up there. We did it. We have not tested every case because every grid has 4 different locations. Well, yeah, it's got a bunch of different cases and corner cases, but that is kind of proving to be working. Let's test more stones. So let's say we put, like, let's just get a big stack going here. Okay, so we've got a big stack over there. Now let's say we only wanted, let's keep it going. Let's keep it going because we're trying to test whether or not we can. I want 13 occupants in this grid. Oh, come on, dude. Come on, man. always index a nil value. It's always that. Come on, man. What? I don't even know what. Crash that. It says in play state 801. So it's in this function. It crashed, and it crashed in our stones to copy. But that's... So our top case is just not working. Can we place a stone here at the bottom? What the? We can't move a singular stone at the moment. Yes, we can. But we cannot move a singular stone if it's about to be 825. So something's going on with our stones to copy? Maybe? I think it's something to do with right here where we would want to use the lowest number . No, this isn't right. Hold on. So if we have less than 5 occupants in our grid, we want to only copy over if we have less than 10 occupants, we can go ahead and copy over all of our occupants. Yeah, if it's 9 or less, we can copy over all our occupants, because we could have 5, but we can't have 5 because this is first. So this is if 4 or less. If our milestone occupants is 4 or less, our milestone occupants is 4 or less, then we can place on a 10 stack all of our occupants. Now, if we have more than a 10 stack, then we only want to copy over the lowest amount of occupants we can place on top of our highest running occupants grid without going over 14. That stopped us from crashing. Now the thing I wanted to test was to place... Oh, give me a fucking break, dude. Bro, why would that crash there that time? So we can, sure, we can move one stone there, but if we place another and try to move that stone, we crash. We gotta print up our highest event, or here we go. Let's print up. The thing we want to print up is our highest surrounding occupants value. So we'll just see. Highest surrounding occupants. And we'll see if this is getting set appropriately. Highest surrounding occupants nil. This should be 10 once we click on it. Which it's not. It actually only gets called once we select it, which is seeming to be working, but then once we place it and drop it and lock that in, it should go back to nil, which it does. Now if we click this one, highest surrounding occupants is 4, which is correct. But what's so weird is now if we click this one, it crashes on 825. It's functioning as expected. And it crashes at the same thing. So maybe our stones to copy isn't getting reset. So let's print up our stones to copy and see if that's going wrong. So, stones to copy would be 1 once we copy one, because it only gets assigned once you click on it, so it's kind of hard to test otherwise. It does get flushed. Can we move a different color? No, we cannot. I wish I could debug values at time of crash, but I don't think that Lua allows that. I don't know how to do that. So where are we going wrong? Why can we only move one stone out of somewhere? Can we do it anywhere else? We can move a stone here, then move a stone out of the same spot, yes. We can only do it if it's something with, there's some sort of logical bug in our 825. Some bug here. It's less than or equal to 10. We copy over all our occupants because we could have 4. Now, if we have more than 10 occupants, okay. If we have more than 10 occupants, but it's crashing with 10. Oh, no, it isn't crashing with 10 occupants. It's crashing with more than 10 occupants. So if we have more than 10 occupants, we want to limit the amount of stones to copy to be this is where the bug is. But we want to be, if we have more than occupants, we only want to copy 4 or less, but it's actually yeah, 4 occupants. Let me write this out. So if we've got 4 occupants, 3 occupants, 2 occupants, or 1 occupant in our mouse grid, which is where we're going to click, then the stones to copy, if we're going into over a 10 stack, would be, let's say for an 11 stack, if we've got, gosh, I don't know how to do this, man. We only want to copy over 1 less than the amount of stones in our occupants. So if we've got we've got 4 occupants moving into an 11 stack, we only want to copy over 3. We've got 3, we can copy over 3. If we've got 2, we can copy over 3. Then we got 2 and 2 and 2, and then 1 and 1 and 1. This is really confusing to me. Basically, our stones to copy needs to be equal to yeah, 14 minus highest surrounding occupants. This is where the bug is, though. For right now, let me just say, hey, we're just going to copy over 1 stone. If we have more than 10 stones there, I just want to see if that prevents the crash. So we should be able to move this one in fine. And then as soon as we try to move this one in, I'm hoping it'll be fine, which it is. So it is, in fact, crashing right here. If our highest surrounding occupants is greater than 10, then the amount of stones we need to copy is 1 less, I don't know, 1 less than the, I don't know. Literally just trying a number there. Nope. So our stones to copy has to be in relation to the amount of stones we have to copy, which is in relation to the amount of occupants in our mouse stone. Well, it would be our mouse grid occupants before we copy them, because we copy them after we get the amount of stones to copy. So let's say stones to copy if our highest surrounding occupants is greater than 10, then the stones to copy is going to be the smaller value, whether it be 14 minus our highest surrounding occupants or the amount of occupants we have. So we're not trying to copy, because we wouldn't have 4 to copy if we only have 2 that we pick up, even though our highest surrounding occupants would be greater than 10, so this actually might fix it. Cool. Oh, Okay. Now, I want to see if we have 13 here. We've got 13 here, and then we've got a bunch here. I want more than 5 here, because I'm trying to test. Okay, we've got 8 occupants here. Now the thing I want to test is, now that this is a 13 occupants, if we pick up from an 8 stack, instead of the old logic where we would pick up 5 because we've got 8, so we would pick up the top 5, we're only able to pick up 1 because our highest stone occupants is actually 13. So this is the case where it's kind of weird, because if we click this, we do in fact only pick up 1. But if we wanted to, this is where it gets weird, because what if we wanted to pick up 5 and move this way, which should totally be legal? Right now we can't do that, because we try to prevent us from dropping any more than the max stack of 14 in that grid. And now, if it's black's turn, this, oh, this is jacked, man. We actually, see, this is another bug. Shoot, man. Because we actually ended up copying over 0 stones in that aspect. So if we copy over 0 stones, it's close. It's close. And it all makes sense. It's just hard to fix. Because it's almost like, oh God, oh God, oh God, oh God, oh God. So what I'm wanting it to be is, if we pick this up right now, actually, hold on. We should only change, okay, we should only change the amount of stones to copy. See, this is not right. This is not right. I was gonna say we should only change the amount of stones to copy if we are surrounded by standing stones or capstones, because then the amount of stones we pick up would have to go in the top space. But if it's not, then we would just rely on the player to not make anything more than a 14 stack. But that still screws us. It'll still crash. So it's almost like when we pick this up, it'll say, hey, like what if now, you know, we pick up 1 stone and then it lets you only pick up 1 stone, because what if you lock in 5 stones to move left, but then you actually just move up into this space. So what we can do is say we're gonna limit you to 1 stone, because in case you do anything sneaky. Now once you lock in your 1 stone, you can place that stone in any direction. But if at this point in time, see, this just doesn't work with how we designed the game, because we should be able to say, okay, I'm gonna move. Well, actually, let's test it, because we can say, okay, I'm gonna move this direction, but I don't want to move 1 stone in this direction. I want to move 5 stones, because I came from a stack over here. So I should be able to, at this point, pick up stones. Oh my god. This is psycho. But once we lock this in a movement event 4, we know, if we know we're not going on top of a stack of 14, then we should be able to pick up as many stones, up to 5 from that movement stone. Jesus. So it's like we need a whole nother movement event. I don't know how to fix it, man. Because right now, pressing down would drop a stone, but what if picking up... Can it work? Can it work where we say, because right now we can't pick up a stone because we haven't dropped any. Oh God, oh God, oh God. But what if we could pick up stones? I don't know, dude. I don't know. It's a very complex problem that I do not know how to solve. Because we should, at this point, instead of just being able to drop a stone, we should be able to pick up the rest of our stones, because it wouldn't be going on a 13 stack or a 14 stack. But if we pick up a stone, God, it's so hard to figure out, dude. What if it was easy to figure out? What if it were easy to figure out? Then in a move in event 4, we just need to add, if up is pressed and our mouse occupants, if our mouse, yeah, at this point we should be able to take stones out of our movement event, movement origin. We should be able to take stones out of our movement origin, place them back into our hand, at which point we would be able to drop the new bottom stone into our left direction. But here's the real tricky thing, is if we pick one up and then press down to drop the one we just picked up in our first movement grid, right here, then we would be able to press up again to pick up a next stone, and then press down again to drop that stone there, which is a totally illegal move. So I'm very stumped. It's almost like we need to, it's almost like we need a special movement event, which is reserved for a scenario like this, where if our occupants over here in our movement origin, if we have less than 5 stones and there are, oh my God, I don't know, more than 5 stones in our movement origin, then we should be able to pick up as many stones as we want to actually move left, then lock it in, then go back to this movement 4 so we can then dump the stones here, which is very complicated, but we need to be able to do this because our fix is busted, because we should be able to move a stack of this size just to the left direction instead of limiting it to only be 1 stone. So this is very difficult and very confusing. I'm thinking though that the move is we do another movement event. We can do a movement event 8, which wouldn't be the 8th movement event, but it would be, be literally the 8th movement event, but not in chronological order. And we would only be able to tell that it's an 8th movement event if we pick up a stone. If when we pick up a stone, we can't pick if when we pick up a stone from a grid that has more than 5 occupants and our mouse stone is less than 5, that would mean that we have an amount near us, a highest stone occupant near us, that's preventing us from locking in more stones than that. So if that happens, then we need to then lock in the amount of stones we have. We would then pick a direction, at which point if we pick a direction and our movement origin grid has, or if we pick a direction and we have less than 5 stones in our hand and our movement origin has I don't know how to do this. It's like if we pick up if we're coming from if we pick up basically if our oh god, I don't know how to do it. Basically, we need a toggle to say that that we weren't able to pick up our max stones. And if we were not able to pick up our max stones because there was an occupant that had a high number next to us, then we have to wait until we lock in our direction to be able to decide whether or not pressing up, and this would be our next movement event, a secret movement event where we would be pressing up to pick up more stones from our movement origin so that we can dump in our next space once we hit enter. Should be possible. God, but it's getting, when it gets more complex like this, it's harder to debug and things break more often because there's more scenarios for things to go wrong. So yeah, we need to come up with something, because if we just, like, let's just say we wanted to move this stack downwards. We wanted to pick up all 4 occupants here and go drop 1 here, drop 1 here, drop 2 here, which would be a legal move. We can't do that at the moment because we lock in only 1 stone just in case you get sneaky and lock that in and want to go up here and dump more than 1 stone. What if we don't do that? What if we do pick up? Okay, I'm thinking of something new now. What if we do pick up? What if we pick up all 5 still? And if because you have to lock in the amount of stones to go to a new grid, we say sure, you can pick up 5, but if by the time you lock in your stones you have more occupants than can fit on the stack above, see, and it's all of this is still wrong because you would be able to pass over a stone only dumping 1 stone in a stack if you can still fit. It's jacked, man. It's very difficult. It's jacked. It's jacked. We just need to come up with a solution that we're generally happy with, because you really can't. This game has limitations when in reality it doesn't have these limitations, and we have to be able to do something. I don't know, man. I'm gonna have to think about it and come up with a game plan, and then come up with what we want to do, how we want to limit those stone movements to make it least intrusive to the player's ability to move stones. Right now, I'm thinking that we still now the reason we pick up 1 stone instead of 5 and then allowing us to drop to lock in the amount of stones or to lock in the legal moves orthogonally is so that if we're trapped, we can't. Actually, no, yeah, if we're trapped and the only direction we can move is on top of a 13 stack, we have to wait until the player manually locks in only 1 stone. So, I think we can do it. And it's a little different than how we implemented today's fix. Because instead of just picking up 1 stone, instead of doing that, we're actually going to be saying, we're going to be using the same logic, which is if our amount is whatever this highest surrounding occupants minus 14, if our mouse stones is equal to the amount of stones that can be copied to our highest surrounding occupants, then we'll allow that grid to be a legal move. I don't know, man. I don't know. It's very complicated. My brain's fried. I'm not going to figure it out right now. But my head's wrapped around the complexity of the problem now. And we'll just have to figure out the least intrusive way to limit the player's freedom in a scenario like this. And hopefully this doesn't even come up. Hopefully a 14 stack or a 10 stack is so rare that the player doesn't even realize that a mood event 9 exists and you can actually pick up. I don't know if we're going to go that route. I'll just have to think about it deeply and try to figure out the best way going forward. We should be able to figure it out. Not the complete solution, but a good portion of it. Tomorrow, I'm hoping so. Holy shit, yeah, today was maybe the hardest day I've had at programming. But I'm gonna watch this video again. Or just think deeply about what we need to do and then try to redo this in the right way. Because we're onto something with this highest surrounding occupants, because that determines how many mousestone members need to be in our mousestone at the time of us locking it in to determine whether or not our next grid is going to be a legal move or not, or our highest surrounding occupant grid would be a legal move. Because but then we need to make sure that we do in fact have a legal move to take all those stones into. So it's very complicated. Yeah, it's just hard. But I'll see you guys tomorrow. Hopefully we'll be able to figure something out. At least get a better idea about what the potential solutions are.